Are you ready to roll up your sleeves and write instructions for the computer? We're going to be writing functions to get our raw data into better shape. This will help us prepare the data to make our later work of creating reports easier. Imagine for a moment, thousands of bushels of apples are picked, but a lot of them need to be looked over to separate the good apples from the bad apples. In the processing facility, you'd have workers looking over each apple and washing off dirt and having the twig trimmed just so. Loading your raw data into data structures is important because you're telling your computer where the data is on your machine, what the structure of the data is, and what should be defined for calculations. The data for our exercises throughout this course is available in data.csv, and we will be using Python code as a way to speak with the computer to provide instructions on how to read the data. Let's open up a data file with Python using the built-in CSV module. Let's first create a new file. So let's first import CSV, and then let's create the function. We pass in one argument of the file name. We create a list that we return. Now let's open up a file name and use the UTF-8 encoding, just in case there are any special characters that maybe have an apostrophe or accent mark. We never know with these brand names, they might have foreign characters. Once we open the file, we can use a CSV reader to read in each line, and we're going to save the output of that to TyReader. And I'm just going to make sure the delimiter here is set to tab because our data has tabs. And then for each line in TyReader, or each line in the data file, we're going to append that, we're going to add that line into our data list that we return. So this will then give us a nested list. Oops, I want line here. One more thing that I want to do is, just in case we have different types of delimiters, I'll pass in a value here, and I'll set the default as tab, but then I can pass in comma or semicolon, etc. And that way it's an optional field. And if I forget to add something, it uses tab. And if I have another type of formatted file, I can use that. All right, now we are ready to try opening up our text file. So we're going to use a variable, data from CSV. And we're going to say open with CSV, and data.csv is our file. Let's print the header from this file. And before I run this, I'm just going to quickly show you that our file, I'm using Vim to show you that our first line has these words separated by tab spacings. And when we read with our function, we're going to have it converted to a list. So let me show you that really quick. So that's how our output should look like. And just as a note, the delimiter here recognize the tab spacing as the place to split each column. So that's how we got a list. Once we have our data in a data structure, and in our case, a list of lists, we can use the concept of creating copies for extracting smaller samples to work with. Let's review a simple sample of a small list. Roy G. Biv. Roy G. Biv equals red, orange, yellow, green, blue, indigo, and violet. And rainbow equals Roy G. Biv. We're going to create another list, warm colors, which contains the first 3 elements of rainbow, and that would mean red, orange, and yellow. We're going to create another list, basic colors, which is Roy-G-Biv from the first to the 5th element, but every other one. So that would lead to red, yellow, and blue. Wasn't that fun? We're going to take this simple pattern of copying list elements into nested list elements with our dataset. Each of the rows is an index inside the bigger list, starting from index 0. Each row itself is a list, and the end result is almost like a map of grids. That's how we can tell the computer exactly what items to work with. Are you ready to see some more cool tricks? We can keep on writing functions for all the repetitive actions and pass in a file name argument instead of rewriting everything. It's like laying down train tracks and allowing a train to get to where it needs to go. If you're new to writing functions, you're in luck. There's some other videos in the Python Basics course that cover these concepts. I'll show you another snazzy tool for working with data. It's called NumPy. It stands for Numerical Python Extensions. This library was designed in 2005 to increase speed and flexibility in working with large datasets. Since then, in the past decade, there have been other libraries created, some with really nifty features that make data analysis super sweet. But we're going to take it slow and steady and cover the basics of a classic, well-known Python library. NumPy provides you with a function to help you generate Python data structure from text, with some options for describing how your text file is formatted. The common ones are describing the delimiter. It's usually a comma, but it might be a tab or semicolon, and passing in the header information, such as the header name and the data types. We're going to try using NumPy now to open text files. And what we can do is use the NumPy generate from text function. Actually, let's import NumPy. Let's create a function load data, passing in the file name. And we want to use NumPy generate from text. And we want to pass in the file name and the delimiter. We're going to use an optional delimiter value that's passed in. And let's say we want to skip our header. So skip one line when we read the file and provide our own. And then also we have 3 more things to pass into this NumPy function. First, we want to say if there are any invalid errors, we don't really want to hear about it right now because we just want to try to read in files. We do want to pass in names for our fields. So I'm just going to set a constant value here that we're going to define in a moment. And then we're also going to pass in data types so that we know if it's a string or a float, etc. So that equals data types. And actually, I have a typo. And I also want to remove these quotes because I don't want the string field names. I want the variable field names. I'm going to save this as my CSV. That way I could just return that variable. All right, now I'm actually going to copy and paste some values. First of all, I'm going to copy and paste in here field names. That is the same list as what was outputted before, except I changed the word from print to pattern for the second to last element. Now the other constant we want to enter here is data types. And this would be defining the data types for each of the fields. So we have the integer type, float type. Integers do not have decimals, whereas floats do have decimals. We also have the string types, which could be A for any or S for string. Right, so now if we were to run this function, we'll now have a global variable called myCSV. And if we were to run this one script again, Oops, I have a typo. Oops, another typo. There we go. It should be D-type singular, not plural. And there we go. We're going to next work on printing the size of this. So to prepare our workspace, we're going to type in clear to make it easier for us to read the console. And then I'm going to close our file.